Okay, I'm Steve Mace from Solwise, and what I'm going to do now is a PowerPoint video presentation covering the ezMaster managed Wi-Fi software package from EnGenius. So this follows on from my previous video where I covered the installation and quick setup of the ezMaster, just getting the package installed and essentially up and running. Didn't go through the configuration, just installed and got it running. So what this video does is, this particular video is going to continue on and actually go through the background and setup procedures, usage of the ezMaster. And then what I'll do is I'll do another video which actually shows the hands-on setup and running of the ezMaster. So say first video, downloading, installation, get it started. Second video, I'm going to go through all the PowerPoint stuff here. And the third video will actually get the software up and go through a basic configuration and setup. So, ezMaster. So, ezMaster is a software package produced by EnGenius. It's been out now for a good year. Maybe more than a year, actually. I said a year in my last video, but I'm thinking it may well be quite a bit more than a year now. But what it is brought out as a software add-on to go with the Neutron Managed Wi-Fi system from EnGenius. So, the Neutron system is a range of access points which can be managed and configured, essentially using a centralized controller switch. So the controller switch can do all of the initial setup, configuration, diagnostics, troubleshooting, blah, 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 for the Neutron managed Wi-Fi package. And to go with that, you've got a range of different Neutron controllers of different capacities, and you've got a range of indoor and outdoor access points to go with that. Yet again, different types of Wi-Fi, different capacities, blah, 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 blah. Right. Now, the limitation on Neutron, or Neutron has always had a few limitations. One of the first limitations is it was limited to 50 access points being managed per controller. Now, to be perfectly frank, 50 access points is quite a lot of access points, and it's not often that certainly we've come across a site which needs more than 50 access points. We've even done quite large distribution sites with warehouses and officing and that sort of thing, and yet again, nothing like 50 access points required. However, that limitation was there, and the ezMaster came along to actually fix that. The other limitation with Neutron has always been that it's really only for a single site. Each site is continued as its own separate entity. So that means it has a Neutron setup and it is just for that site. So if you actually wanted to do multi-site configuration, each site would have to be treated as its single standalone object. Yet again, ezMaster has come along, and the aim of ezMaster is you can collect several individual sites under a single banner called a project. So a project is a number of individual Neutron sites all brought together under a single configuration umbrella. Okay, now all this sounds fantastic, and one of the worries is, well, how much is it going to cost me? Well, the good thing is ezMaster doesn't cost you a dime. You go to the EnGenius website or the Solwise website and you can download ezMaster. It's free to run, there are low licenses, all the updates are free. All you do is download the software and install it on a suitable computer. ezMaster has been out for a while, and you can go to the EnGenius site or the Solwise site to now know the latest version. Now, the way ezMaster works is it is what they call a VM application. So basically, it's a piece of software that needs another piece of software to run. You don't have to necessarily understand what a VM application is, because the whole system, the way ezMaster works, is it's designed to actually isolate you or insulate you from all that horrible technical garbage. You don't have to understand any of that. Just think about it that ezMaster needs another program to run, and the other program is what they call a VM player. Now, VM players are systems used on servers typically to enable multiple applications to run on their own isolated environments. Yet again, you don't have to worry about it getting confusing. It's not going to get confusing. All you have to know is you download the VM player, you install the VM player on your Windows computer, and you're up and going. So, let's continue. So, the traditional target deployment for ezMaster has really been aimed at the installer. So the installer can have multiple sites, as an example here shows split between different customers, and the installer can centrally manage all of his remote customers from his one HQ location. So that was the normal target market for ezMaster. But in actual fact, it really suits anybody who actually wants to be able to do multi-site operation and or sites with very large numbers of access points. So we're talking about, 1,000 access points, that sort of thing. So background really, if you're going to install ezMaster, you need to decide who's going to manage the network. So who is going to configure and manage and maintain it? Do you want to are you as the installer going to do it, or are you just basically going to give it all over to the customer so you can do it themselves? Key things that you need for the ezMaster is it does need to be able to see the internet. So obviously that is related to where the person is located. So wherever the server is located that's going to be running the ezMaster, you do need to have an internet connection for it. The internet connection is required for the ezMaster to actually talk to the outside world, but also for your remote branches to be able to talk back to the ezMaster. The other alternative is that although the ezMaster still has to see the outside world, what you can actually do is run the ezMaster as a local installation at a site. So if you've got a site which doesn't necessarily need the multi-site capability, but it does need the very high number of access point capability, then you can install ezMaster on a suitable Windows or whatever type PC in the building to actually manage and run the whole network. What's typically traditionally with Neutron, what you have is at the core of a Neutron system, you have a Neutron Controller Switch. So this is a normal IP switch which has the Neutron Controller Wi-Fi management software running on it. So normally your Neutron system would have been a Neutron controller and a collection of access points. Now it just so happens that for ezMaster, although it is better for you to have a Neutron Controller Switch, you don't have to have a Neutron Controller Switch. By that I mean you can actually run Neutron access points at a site. They will still be centrally managed by the ezMaster, but you don't theoretically need a Neutron controller at the site. So you can have some sites which have a Neutron controller, and you can have other sites which just have the access points, yet again talking back over the internet to the ezMaster. So the question comes, well, if I don't need the controller, then why should I go through the expense of putting a controller in there anyway? Well, this little Venn diagram here shows you the pluses and minuses, what you get if you actually put the ezMaster in and the switch in both combined. So there are various features and functions here which a controller at a site will give you, which you won't have if you don't actually, if you just rely upon the ezMaster. So a lot of the enhanced troubleshooting which the controller switch gives you is lost if you just use the ezMaster to manage a remote setup of access points. So now it used to be the Neutron controller switches from EnGenius. I'll be perfectly frank, they were a little bit pricey. So there was obviously a bit of an incentive there to see if you can get away without actually having a Neutron controller switch at the site. Now things have changed. Sort of mid last year, mid 2017, EnGenius rethought the strategy for the Neutron switch range, and what they did was, the result of that was a whole bunch of different Neutron switches came onto their product range, and at the same time a significant restructuring of the pricing downward. So now the argument goes, well, most sites you're going to need a switch anyway. So if you're going to put a switch in anyway, you might as well make it a switch with the Neutron Management in it. It's not going to cost you any more. And if you've got the Neutron Management in there, then it will give you a better system for managing your Neutron access points at the site. So that's the way, that's the argument now. So let's go through the various options here. So if you have a controller switch in, then you can actually use ezMaster at the site to locally manage your controller setup. So that's this sort of scenario. There's option B. Option B is the ezMaster managing the local Neutron system consisting of access points and a controller switch at the same site. Also, the ezMaster at that site can be configured to manage the a Neutron system consisting of controller and a collection of access points at a remote site. Also, that ezMaster can actually be used to manage a collection of Neutron access points at a further remote site which doesn't have a controller. So really this is showing the three different systems that the ezMaster can actually be incorporated into. So it can be locally configured, locally managing site, remotely managing a full Neutron site, or remotely managing a site with just a collection of standalone access points. These have to be Neutron compliant access points, but option C here means you don't have to put a controller in. Yet again, going back to the previous couple of slides, I would argue you're going to need a switch at the site anyway. You might as well put a Neutron switch in, because by putting a Neutron switch in, it does give you all of those extra tools for troubleshooting, etc. This is a table which really is also a very similar table what's been presented on the actual videos, the PowerPoint presentations, when I'm actually specifically just talking about the Neutron system. So what ezMaster does is it replicates all the functionality that you would see in your Neutron controller setup. So if you go back to my previous videos where I've gone through the configuration of a Neutron system through the controller, all the functionality that you see in ezMaster has essentially just been replicated from the controller. So all of these functions and features here, this is a function and feature list of what ezMaster gives you for your Wi-Fi management. All of these features and functions are essentially exactly what you would get if you were running a site with a Neutron controller and a collection of access points, but without the ezMaster. All it does is it replicates the functionality that you get in the controller and replicates it onto the ezMaster software system. So what we're going to do now is run through the four categories of management and configuration and troubleshooting that the ezMaster gives you. If you've already gone through the Neutron videos, this will all look extremely similar, because it's virtually identical to what you get when you do a Neutron controller management. So if we go through centralized management, so this is something that ezMaster gives you which Neutron does not. So this is one of the things that I've already mentioned, the ability for ezMaster to manage Neutron systems across various sites. So it's got cross-subnet capability. With Neutron, the controller can only see the access points which are on the same subnet. ezMaster, because it's got the tools in it to cope with multiple branches and multiple sites, also naturally has the tools to cope with cross-subnet capability. So it doesn't matter where the ezMaster is, as long as the ezMaster and the access points can see each other through the network or through the internet. I've already mentioned this concept of a project. Up to now, if you've been playing around with the Neutron controller switches, you had this thing called a cluster or group of access points. So each cluster or group had a number of access points within it, which are all managed or configured under the same group of settings. And each Neutron switch can have multiple groups. Now, for example, this could be, I don't know, first floor, second floor, third floor, fourth floor, or it can be main building, remote annex, factory floor, blah, blah, blah. So each group or cluster of access points were a bunch of access points, but all under common configuration settings. Now what ezMaster does is it puts a further layer on top of this called a project. So you notice now we've now got 3 layers to the model. So a project manages a number of groups, and each group manages a number of access points. So you may have a project which is multiple sites. You may I'll give you an example. You may have a project which could be a customer, and that customer may have several shops. So each shop can be an individual group. So the project is the customer, each shop is an individual group, and each group has a collection of access points at that shop. So it just adds that extra layer on top. So that was centralized management, and now we're going to look at access point configuration and management. So this is just going to go through each of these features in quick succession, describing what the ezMaster Wi-Fi management system gives you. But yet again, this is just reiterating what I've already discussed in previous videos as far as what the actual Neutron system will do anyway. So the first thing that comes up is background scanning. With background scanning, the access points are constantly, regularly polling the neighborhood, the RF neighborhood. So what they're doing is they're checking the RF neighborhood and looking at things like channels, any rogue APs, am I operating on the right power, etc., etc. So, and what they're doing is they're taking that information on board and constantly changing the parameters of the channel they're operating on and the RF power they're actually throwing out. So this is a system which is constantly dynamically in flux. So it's constantly checking that the whole system, all the access points as a whole, are running with optimum operation. So minimum interference and minimum RF power. You don't want to be cranking the RF power up too much. If you crank the RF power up too much, yet again you get interference between the access points. So what they're doing is checking to make sure that they are not interfering with each other while still giving the maximum coverage, RF coverage, for the client connectivity. And that is actually set up yet again on the ezMaster screen. If you've seen the Neutron videos, you'll recognize this screen, this GUI page here. It's exactly the same as you actually get on one of the Neutron system. And all it's showing is here we can tick the boxes to enable or disable background scanning for the 2.4 and or the 5 gig. Although it's okay for access points to randomly change their channel, it can be a hassle if they randomly change the RF power. Now the reason is if an access point decides to change its channel, there is a protocol in place which I think is called 802.11h, whereby the access point can communicate with any connected clients and warn them that the channel is about to change. That way the clients can react and make sure that when the access point does actually change channel, the clients change at the same time and there's no breakdown or interruption to data traffic. However, there's no such protocol in place for randomly changing the RF power. So the issue there could be that if a access point is talking to a client and that client is on the edge of being able to actually work as far as the signal strength is concerned, then if that access point just suddenly decides, oh, I'm going to halve my output power, my RF power, because of interference issues with other neighboring access points, then that could end up with that client being kicked off and floundering in the big bad world. So the ability to do auto TX power has to be used in moderation. What I normally tell people to do is by all means enable auto channel changing. But as far as auto power is changing, I usually tell people, set your Neutron system up, get it working, get all the access points installed, configured, etc. And perhaps leave the auto power set up for a short period of time, maybe only 24 hours or something like that. Just so the system's had enough time to analyze the surroundings and work out what is the best or optimum power for it to run at. Once it's set up, then go back and disable that auto TX power, just so you don't get it randomly kicking clients off. And this is just showing an example of how the auto transmit power works. So typical setup showing a bunch of access points, and this is showing with the auto TX power how it can actually turn down the RF power of the access points to limit the interference between the access points, but still give the optimum coverage for the areas between the access points. On the same thing, yet again to do with background scanning, this is just showing how the access points can randomly change their channel. And I was right, yes, it is 802.11h, so they can randomly keep changing their channels, and if they have to change a channel, then any connected clients are warned about it using the 802.11h protocol. Next feature down on that table, about 3 slides back, was client limiting. So ezMaster, yet again, just like Neutron Controller, ezMaster has the capability to actually limit the number of connected clients. And that's actually available through the wireless settings. So under the wireless settings, you can actually control the actual client count per interface. So this is the 2.4, the 5, and the 11AC. The default is 127. But what you can do is take that down to a more sensible number, and if it's a more sensible number, then if an extra client tries to connect, it will be refused, and that will force the client to go look for a different access point, and in that way you can actually equalize the client connectivity between the different access points, the client load between the different access points. Right, so let's go look at the multiple SSID functionality. So all of the EWS access points, it says most on this slide, but I've got a feeling it's all. I don't know one that don't, but all of the EWS access points support 8 SSIDs per radio. So in this example here, there are 8 individual SSIDs for the 2.4 and 8 for the 5 gig. Each SSID has its own private security, its own isolation settings, and its own VLAN tag options. And by default, out of the box, only the initial SSID is actually enabled, but you can, if you want, go through and set up multiple SSIDs for different classes of users. So if it's a school, you could have, for example, you could have staff, you could have pupils, you could have guests, with different isolation, different VLAN tagging, and different Wi-Fi security on each of those SSIDs. Under each SSID, we've got individual isolation control. We've got client isolation control. Now, client isolation control basically means clients seeing each other through the same access point. We've got layer 2 isolation. Layer 2 isolation means clients seeing each other on different access points. And you've also got VLAN isolation. So you can actually go right down and actually do traffic isolation through the switches, etc., and the infrastructure of the actual network. We've also got traffic shaping. So with the SSID, you can actually set up a minimum maximum bandwidth per SSID. So this is just showing a pictorial representation of what I meant when I said client versus layer 2 isolation. So with client isolation, A can't see B through that access point. So both A and B are connected to the access point, but they can't see each other through the access point. With layer 2 isolation, A or B also cannot see D or C. Okay? So if we take out the layer 2 isolation, then A can't see B, but A can see D or C. We put in that isolation, and immediately we end up with an extra level of isolation such that all the clients are effectively isolated from each other. Now, word of warning if you do that, some of the clients may be infrastructure on the network that you do want to be able to see. Typical example, network printer. If you put in a layer 2 isolation, you may have issues seeing network printers on the network. So use it with a pinch of salt. And this is going back, so I said, yes, you've got client isolation, you've got layer 2 isolation, you've also got VLAN isolation. So VLAN is a system whereby SSIDs can be given a VLAN tag, and going into management of the infrastructure through the switch and the other network infrastructure, you can actually steer or direct that particular VLAN tag traffic only to specific destinations or equipment. So this is saying, look, we want VLAN 1 to only go to the hotspot gateway, VLAN 2 to blah, 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 VLAN 3, blah, 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 blah. So this is just a way of actually steering specific tag traffic to only see specific infrastructure equipment on the network. And remember I said you've got traffic shaping per SSID. So with traffic shaping SSID, you can actually specify the upload and download speed permissible on that SSID as a whole. Okay, so that is total traffic in and out of that specific SSID. It's not per user, it's per SSID. We've already discussed traffic shaping per SSID. We've already discussed client limitation per radio. We've also got a further data traffic and client control feature, which is actually done per AP. Now the bandwidth control per AP is actually done through the Neutron switch. So this is one of the functions that you get if you put a Neutron switch in, which you don't get if you just have the access point sat there at the site using the ezMaster as management. You don't get any bandwidth control functionality of the access points. That is done through the actual switch, and it's done on a per port basis on the switch. And the way we do that is you actually go into the Neutron switch management. Yet again, it will be useful if you actually have already been through the actual Neutron videos, because you'll recognize this screen because I've already covered this feature and function on my Neutron videos. So you go into the switch functionality, you go to bandwidth control, and under bandwidth control you can actually specify the in and out throughput limitations per port. And obviously that means per access point, because each access point is connected to a port. Fast roaming. Right. All of the Neutron system, and that means a Neutron system with sites either which have a neutral controller or just standalone access points. Either type of site supports full 802.11k and 802.11r roaming protocols. Okay, now I've been through roaming protocols before in previous videos, but quick recap. 802.11r is a protocol whereby when a client is about to move access point, it can pre-negotiate security before the move, streamlines the process of hopping across. 802.11k means that when a client is deciding that it's perhaps time to think about moving, it can interrogate the access point it's currently connected to give it a snapshot of the access point environment around it. So yet again, what that means is that the client can try to make a sensible decision of where it's going to hop through without actually having to go through the process of breaking off from the access point. So client decides, oh, I think I'm going to move, talks to its current access point, says, give me a list of the RF environment. With that list of the surrounding access points in the RF environment, the client can then decide which access point it's going to connect to, and then through that first access point can then negotiate the security handoff to the second access point. So it can get all of that out of the way before it actually hops across. Most client devices nowadays are dual band. By that I mean they support 2.4 and they support 5 gig. Now the 2.4 band, 2.4 gigahertz band is really very long in the tooth now. It was the first mass market Wi-Fi band. Just about every single client device supports 2.4 gig Wi-Fi, but the problem with 2.4 gig band is it's very small. It's got a very small number of channels, and by that I mean channels which don't suffer from cross-channel interference. In effect, there are actually only really 3 channels available in the 2.4 gig band which don't give you cross-channel interference. Now if we compare that to the 5 gig band, But anyway, 5 gig band actually has a much wider channel base. Off the top of my head, I think it has like, oh, somebody's going to probably correct me on this, but I can't really remember. Is it something like 14 channels or 15 channels? I can't remember. It's got a very much larger number of non-interfering channels. So what that means in practice is it can actually cope with a much larger number of clients, but without suffering as much interference between the clients as the 2.4 gig. So anyway, so it's preferable to try and push the clients if they are dual band. So if you've got clients which support 2.4 and 5, it is better to actually try and push those clients onto the 5 gig. That means the clients will operate better because they're not interfering with each other as much, and it also means you're leaving the 2.4 gig band open for those clients which still don't support 5 gig operation. And there are a lot of legacy products out there which don't support 5 gig. Things like barcode scanners and that sort of thing, which still don't at this stage support 5 gig Wi-Fi. So the capability of an access point to coerce clients onto the 5 gig in preference to the 0.4 is what we call a feature which we call band steering. So with band steering, what actually happens is the access point interrogates the client. If the client which has tried to connect to 2.4, if that client's actually capable of doing 5 gig, then the access point will try and coerce that client onto the 5 gig band instead, hence leaving the 2.4 free for other users. Okay, RSSI threshold. So another feature which you can do, and this is all to do with trying to encourage clients to roam. The thing about client roaming is it is the client that decides if and when it is time to move access points. Now, what the client does is it analyzes the signal strength, the amount of traffic errors it's getting, etc., the signal to noise ratio, all that sort of stuff. And it's the client which, if it reaches a certain degradation of the signal, degradation of its data throughput, it's the client will suddenly go, oh, this is a bit rubbish. I think I need to start thinking about hopping across to another access point. Now, some clients are good at that and some clients are bad at that. And by good or bad, what I mean is some clients are very quick at making a very sensible decision as to whether it's time to move across or not. And some clients are as stubborn as hell and will stick on grim death to an access point, even though it's plain to anybody with an ape of sense that that connection is really bad. You've all seen the situation whereby you're on your client device, the internet's appalling, your YouTube videos are conking out, your VoIP calls won't work, and it's really annoying when the real reason is because the client is still connected to an access point which is giving an appalling signal, which is, let's say, I don't know, 3 rooms down the corridor, when you have a perfectly good access point literally just 3 foot above your head. So it is the client that actually decides whether to move across or not. Now, to try and encourage clients to move across when they won't, the access points, the neutron access points, have this thing called an RSSI threshold. So with an RSSI threshold set up, what the access point does is it monitors the signal strength from the client. And you set it at a certain threshold level. If the access point detects that the client's signal has dropped below that threshold, then the access point will kick the client off. That will therefore force the client to have a look around on the neighborhood and force the client to choose another access point for it to move across to. The problem with this approach to actually kicking the client off is it does tend to make a kibosh of roaming. Remember I said there was all those protocols, 802.11k and 802.11r, which are designed to enable a client to make a sensible roaming choice and decision, pre-negotiate security, etc., and only then hop across once all that's been sorted out. Now, if you're going to do this by the brute force way of suddenly kicking off the connection to the client is in a position where it's just like the K&R roaming doesn't exist. It's got to go through the process of interrogating the environment to find a suitable access point to connect to. That would have normally been covered by 802.11k. It's also got to then go through a process of Wi-Fi security negotiation with that access point. That would normally have been done by 802.11r. So it does mean that there can be a definite noticeable lag in the client renegotiating with the finding and renegotiating with a new access point. As to whether that's important or not does depend upon what the traffic is that the client's involved in. If it's just doing a bit of web browsing, you know, a bit of that sort of social media garbage and all that sort of thing, then the fact that there's been a couple of second gap or a second delay in the latest bit of website browsing is not going to be noticeable. If that client, on the other hand, is involved in something like VoIP call or something like that, then it could be quite a big impact on the call. It may even cause the call to actually be terminated. So something to be used with care. And also one thing to consider is what your client devices are. Now with Android devices, there are some quite cool apps that you can download, which means that you can actually have the tools to actually manage and control the aggressiveness of the client's tendency to roam. So you can actually tune your client so that it makes a speedy and sensible decision as to when to roam. Those tools don't seem to be there for Apple products. So with Apple products, you're really relying upon the built-in features and functions of the Apple operating system or Apple hardware to do that. Let's just show the setup screens for the LED control, the band steering and the RSSI threshold. So this is just showing you what the setup screens look like. As you see at the top here, you've got the tools to actually enable and disable the flashing LEDs on your access points, whether you want to enable or disable the band steering, and do you want to actually use an RSSI threshold. So this is all accessible through the group configuration. So this would apply to a group of access points. Next feature on that list, if you remember back that long ago, is a guest network function. Originally, when the Neutron system came out, the powers that be, in my opinion, quite sensibly, but the powers that be did actually decide that really having a hotspot gateway, captive portal type functionality in the actual Wi-Fi management was not really part of the remit of the managed Wi-Fi system. They quite sensibly rationalized that really that should be the remit and the control of a separate hotspot controller sitting on the network. However, they bowed to public pressure. A lot of people kept on asking, no, we want a guest network, no, we want a guest network. So what they did was they went ahead and introduced a limited functional guest network. So they have a guest network. Each access point has a guest network for the 2.4 and a guest network for the 5 with individual Wi-Fi security parameters. Now the way this works is each access point is actually pretending to be an individual isolated Wi-Fi router for those connected guests. By doing that, it means that it has very good isolation of those guests from the network as a whole. So those guests can see the outside world, but they can't see any of the other client devices or any of the other users on the network. And this is why at the bottom here under the guest network, you see we have some IP settings. So these are the IP settings for the actual Wi-Fi router part of the access point. And also here we have a system of enabling or disabling a captive portal. The captive portal really is quite a simple thing. It's not a super sophisticated thing. It doesn't give you all the function features that you would get in a proper hotspot gateway product. So it doesn't give you things like, I don't know, social media logging in. It doesn't give you things like PayPal charging, different bandwidth protocols for different classes of users, different timing out or authentication time periods for different classes of users. It doesn't give you any of that. In my opinion, the only really thing it gives you is what I would call a splash and go page. So client connects, up pops a screen saying, hi, welcome to Joe's CAF. Please tick the box here to agree to our T's and C's, and then you can go off and do some Wi-Fi stuff. So, but it's got that. And the way it works is you have a series of different captive portal profiles. Each profile effectively is a different splash and go screen. So if you want the guest network, you go through the actual individual SSIDs and enable it here. And if you want the captive portal, you tick on enable and you select a suitable profile for it. And this is what the actual profile looks like. That's under the profile settings. Obviously, when I actually do the proper hands-on demonstration in the ezMaster, you get a better idea of where these screens are located. So under the captive portal settings, you actually can have multiple profiles. You give the profile a name. Under that, you can have different authentication types. You've got splash and go, which is the most common use for this. It does have the capability to use databases of users. So that's username and passwords, but it's so cumbersome and so inadequate that I wouldn't even consider it. I would only consider this really as a splash and go option. And also, EnGenius are thinking of writing in the capability to work with third-party authentication systems. But the only one that I've ever seen mention of is this called Cloud4We. And as far as I know, that's only a US-based system. So you might as well ignore that. Splash and go, that's all it really does. So this is going through it. So captive portal, splash and go, you'll land on splash and no authentication needed. You can have a local database, which is a list of username and passwords that you can enter into it. You could use a radio server if you wanted to, yet again with a list of username and passwords built into it. Or you could use an external captive portal service, but as I say, none of those have been developed yet, so I wouldn't even think about it. If you were going to use a splash and go, you can either use your own pre-written external splash and go URL, or you could actually just use a simple template splash and go page, which is actually built into the ezMaster. So you select a logo and you put a message in and you put some T's and C's in and tick them as to whether you want them to be shown or not. Okay. This is if you actually wanted to use the local database for the guest account. So this is just where you actually create your own little username and password list, which is stored inside the ezMaster system. Here it is just creating a thing. So that was the guest network, captive portal. So good for splash and go. I'm not convinced about anything else really. Let's continue through our comprehensive table here. Monitoring tools. So let's go through the various monitoring tools that ezMaster gives you. So there are 3 levels of monitoring. There's clients per access point, there's the access points, and there's the system as a whole. So the system as a whole, that's really just this status page that tells you what's going on in the system really. How many managed devices are, uptime. And this is impressive. This system was up for 54 days before they did the screenshot. There you go. Really short projects and the resources available and being used on the system. So let's do device monitoring. And under device monitoring, we can go to access points. Under access points, we have the individual access points shown. And if we continue on, under each access point, we can get stats for the traffic throughput and the client number for all of the access points. And we can also look in detail at individual access points, showing how the client number and the traffic has actually changed over the last 24-hour period. Also, you can get that in real time. So it basically will give you a snapshot in real time of what's going through for the last 120 seconds. And I say snapshot, that's not quite true. This is dynamically scrolling across all the time in real time. More sort of stats that we can do. So we can look at the individual clients that are connected for a specific access point, and we can look at the actual throughput. for individual clients. This is showing the MAC address of the clients. This has actually improved since this screenshot was taken, and now it actually shows also the fingerprint for the clients as well. So you don't just have the MAC address, you actually get the fingerprint of the client, so the client's name as well on there. And here it is. This is just saying, so this has been tacked on since that slide was shown, whereby it will actually give you client fingerprinting. So rather than just having the client identified by a MAC address and the AP they are connected to, you now get extra information which gives you the name of the client and the operating system being run by the client. So you get the MAC address traditionally, plus you get these 2 extra columns of information now with the client fingerprinting. Further topology tools, there's the visual topology view. So what this does is it draws basically a route topology map for the interconnectivity between the various switches and the access points. So this is drawn on demand, so at any one time it can give you a snapshot of the interconnectivity between the various elements of the network. So these are the various switches in the system, and these are the access points that are distributed around the system as well. Now, if you use the EnGenius switches, then you can get further information on the actual switch infrastructure as well. If you're using non-EnGenius brand switches, then you don't get any information at all. It just says there's a switch here, but I can't tell you anything about it. Floor plan wireless coverage displays. Now, I did go in yet again into these in quite detail in the Neutron videos, but what they are system whereby you can load a number of floor plan views, and on each floor plan view you can place the various access points pertinent to that particular plan view, and also it'll actually give you a RF coverage contour map showing the signal for each access point. Now, the only problem with this, and I've gone on about it again and again and again, is this may look pretty, but it is completely useless. And the reason it's useless is because it doesn't take into account how the signal degrades or is affected by the walls of the building. You notice here that you've got these signals going through, and there is no change when the signal actually has to go through a wall. In reality, obviously, what you would see is strong signal, strong signal, strong signal. As soon as it goes through the side of the wall, considerably weakened signal. So this looks pretty, but in actual fact has limited function and limited use. However, EnGenius have actually redeemed themselves now by producing a really excellent and superb online wireless coverage design and implementation tool. It's on the EnGenius.com.sg website. And what it does is it will enable you to, you can use it as a manual process. By that, when you upload plans, there can be indoor plans or outdoor map plans. You can advise the system as to the topology and the makeup of various obstructions. So, for example, if it's a floor plan, you can tell it things like what this wall's made out of, what this wall made out of, and it has a built-in database of typical signal degradation factors for different surfaces and different materials. You can use it in a manual scenario whereby you can place the access points on the map, and it will give you an indication of how the signal will propagate and will be degraded by various surfaces that it's actually got to go through or got to go around. But also you can use it in automatic mode, where you can actually draw regions on it saying, right, I want Wi-Fi here, 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 here. Go and tell me what access points I need to use and where I need to place them to give me that coverage. And under that mode, it'll then go along and actually draw optimized places and locations for the access points and show you what the coverage would be if you took those suggestions. So really good tool, fantastic tool. It came out of the blue. We didn't know such a tool was being developed, but we've played with it online and it really is fantastic. And also there's a really good training video which has been done by EnGenius, which actually covers this Wi-Fi coverage tool. It's really good. But anyway, coming back to this, yeah, it's okay. It looks pretty, not much copper. And they've got a similar one for outdoor This one really is just a way of actually giving an indication of where you've put your access points outside. So you can use Google Maps to actually bring up a map of a particular site. You can drag the access points across and place them on the map, and then you can save that map for later checking and reference. Rogue AP detection. Now this is something which is actually done as part of the background scanning system for the access points. So the access points, remember, going back to background scanning, the access points are constantly polling the environment to see about different channels and different RF power being broadcast. And as part of that system, what they're actually also looking for are access points which it detects them, which aren't part of, but they aren't part of the actual Neutron or ezMaster system. Okay, the final one, management and maintenance. So if we go to look at the active client list, we have the tools to kick and ban clients. So if we kick a client, that temporarily disconnects the client, forcing them to reconnect. If we ban client, that completely blocks them. Once they have been blocked, then you actually have to, they then have to be manually unblocked. So they stay blocked then until somebody, administrator or something, actually has to go into the management of the system and tell that client they now have free access again. Okay. Seamless migration. Right. So let's go through a typical example. You put a site in. A site consists of a controller and a collection of access points. And that site's been running perfectly okay for a number of months or a number of years. You then want to actually take the management a bit further so that you can use ezMaster then to do remote management of that site. So there are a number of different ways whereby you can bring that Neutron environment into your ezMaster system as part of a project. Because once it's part of a project, then you can actually manage that site remotely through the ezMaster system. So one way to do this is they have this thing called seamless migration. Now what it really means, or what it means, is that you can actually go to the controller. You can go into the controller, you can tell it details of where your ezMaster is, and you can then say, right, now go through a process of automatically incorporating this setup being the controller and the access points, into this specified project at the ezMaster server. Next on the list was the one-click update. Yet again, this was already there in the controller switch, but as part of, so it's also there in the ezMaster, and it's a way whereby the ezMaster can do automatically checking for available updates for all of the hardware which is actually being managed and controlled as part of the ezMaster server. You've also got bulk firmware update features. Yet again, exactly the same thing, sort of thing as you've seen in the Neutron controller, whereby you can upload a firmware file and bulk apply those firmware upgrades to a list of devices which are being managed. You've got Wi-Fi scheduling, same as in the controller. What that means is you can set up a series of tasks that you want to schedule to happen at certain times of day. For example, you may want to turn off a specific SSID out of hours. You may actually want to completely switch off some access points at certain times of day. You've got the normal event logs, that same sort of event logs that you also saw when you were actually using the controller. So you've got event logs telling you about clients leaving and joining networks, administrators joining and leaving the ezMaster, etc. You've got the tools to change the username and password for the admin account, remote logging settings, a remote logging list, and the tools to actually reset the ezMaster. You've got tools for email alert. So same thing, this is already there in the controller, but what it means is that you can set up an administrator who can be emailed when things change within the network. So for example, an AP has been lost, a topology change, or an access point is bottling out because the number of clients is actually reaching the predefined threshold. These are typical type of events that you can be emailed from. And this is just showing that there's a setup screen where you put in details of the SMTP server and the actual recipient of the email. This is a specific ezMaster tool which is to do with connectivity checking. Remember I said, already covered the fact that the way ezMaster communicates with the various sites and the various hardware is through the internet. So it's very important that the ezMaster, if you're going to be managing and controlling remote access points or controllers, obviously it's very important that the ezMaster has free access over specific ports to the internet. So, and that can be checked by going down to the diagnostic connectivity test. What this means here is that there is a firewall or something somewhere which is interrupting the connectivity of the ezMaster to the outside world. Now, there are two things that you need to sort out with the ezMaster to work over the internet. One thing is the ezMaster needs to be able to see out, but the other thing is that the various Neutron elements also need to be able to see in. And to that you do need to do some port forwarding. And so there are various ports that you need to forward from the outside world to the ezMaster. And port 1234 is a key one. Port 1234 is a key port used in equipment management and control, Wi-Fi equipment management and control, and that has to be forwarded to the ezMaster. If you're going to use the ezMaster in a local installation, so it's locally installed to look after a local Neutron setup, then this is not so critical. It doesn't really have to be able to worry about devices coming in from the outside world. But if you are actually intended to use the ezMaster to remotely manage sites, then you do need all of this sorting out and these ports forwarded correctly. One of the things about Neutron, and this applies to ezMaster as well, is that all of the different elements of the system have got enough intelligence to continue running perfectly in perfect operation, even if something goes wrong to their connectivity back to the management device. So what I mean by that is if you've got a Neutron controller and some access points, then you can use the controller to configure and set up the access points. But if something happens to that controller, somebody compels and pulls the mains lead out of it, for example, as long as the access points are still powered up, they'll still carry on running, they'll still carry on doing things like the roaming, they'll still carry on doing things like the guest network, etc, etc, etc. They'll all carry on doing that even without the presence of the controller. Similarly, if the controller and the system is having to talk back through the internet to ezMaster, if something goes wrong with the internet connectivity, then the systems at the various sites will still sit there running perfectly okay as standalone inherent systems without actually being able to see the ezMaster system. So you can use the ezMaster system to set them up, get them all working, and to manage them. If the internet breaks down, each site will sit there running perfectly okay in isolation until the internet comes back up again. When the internet comes back up again, then all of the log and statistical information pertinent to each site will then be uploaded and sent through to the ezMaster for the administrator to check. So this is just reiterating the same sort of thing. The internet fails connectivity to the ezMaster. The two sites sit there running perfectly okay. And then once the internet comes back up again, the two sites do a hurried process of updating the ezMaster with effectively all of the logging and traffic information that's happened during that downtime. So that was, I must admit, that was a rather hurried go through of a PowerPoint presentation explaining to you the ezMaster, how it fits into the system. 90% of all the different features and functions I've shown you, if you've gone through the Neutron system videos that I've done, you've already seen before. It was just basically regurgitating what you've already seen. A lot of the screens that you've seen are exactly the same on the ezMaster as they were on the Neutron controller. So you've seen a lot of that before. So I did actually try to rush through it a bit there because if you've been through the Neutron thing, you've just seen it. You've seen it already, so it didn't really tell you anything more. But what I'll do on the next video will probably be a little bit more interesting. I say, first video, I've already shown you how you can download and initially install the elements of the ezMaster. That's both the VM player and the ezMaster software itself. So what I'll do on the next video is actually show you actually getting the using the ezMaster. So I'll go through the process of migrating a traditional Neutron controller plus Neutron access points into the ezMaster, and then quickly flash through the different setup screens and that sort of thing on the ezMaster. Yet again, there's no point in me labouring that part because 90% of it you've already seen on the Neutron system videos. But I do find that people like a little bit of hands-on stuff, because sometimes I think they're under the impression that, well, he's been all this waffle and that sort of thing, been pretending it's easy, but it won't really be. But if I can show you a real-time live run-through, then it just builds up your confidence and makes you appreciate the fact that no, this is quite easy. It's not rocket science. It doesn't have to be confusing. So anyway, that's the end of that video. Thank you very much.